Hello, 8th graders. This is Teacher Monica, and welcome to our learning session. Today, you are going to learn about basic geometry. I will be discussing undefined terms and some defined terms. When we say undefined terms, it is the most fundamental concepts in geometry that do not have precise definitions, but we understand their meanings intuitively. Point is one of the undefined terms in geometry. It is being described as something that has no length, no width, no height, and thickness. It can be named or labeled with one capital letter and represented by a dot. Say, for example, in this figure, we have 3 points named point A, point M, and point J. It uses capital letters to represent the dot or to represent the point. Another undefined term in geometry is line. Line is described as something that extends in one dimension. It is usually represented by a straight line with two arrowheads to indicate that the line extends without end in two directions. Say, for example, in this figure. So the line extends infinitely in downward left direction. And on the other side, the line extends infinitely in upper right direction. This figure can be named in two ways. First is by using a single lowercase cursive letter like line N. If you can see, we have there a small letter N, and this represents the line. So we can call that line as line N. Another way of naming this line is by using any 2 points on the line. Now, if you can see, there are 3 points on the line. We have point J, point A, and point M. Using any 2 points on the line, we can name this line as line JN, or in that figure, line JM. Remember, it uses capital letters with double-headed arrow. We can also name this line as line AN. And we can also name this line as line AJ. Note, never name a line using 3 points. Use only any 2 points on the line. Now let us take a look on the properties of a line. A line has infinite length. It extends in both directions infinitely. The lines do not have any endpoints. It is one-dimensional geometrical figure. Intersecting lines will cross at only one point. 2 points determine a line. Next, we have plane. This is also one of the undefined terms in geometry. Plane is being described as something that has infinite length and width, but no thickness and edges. It is a flat surface and can be named in a single upper script letter or by 3 non-collinear points. Say, for example, in this figure. This figure can be named as plane M. It uses the single upper script letter. Or we can also name this plane as plane JAY using the 3 non-collinear points. Aside from plane JAY, we can also name this plane as plane AJY or plain YAJ. Did you get it, students? Now, here are some of the real-life examples of undefined terms. In the figure, we have tip of a pencil. That is representing a point, the tip of a pencil. The mole on the face also represents a point. A straight road represents a line. The edge of the table also represents a line. The tabletop represents a plane. The floor represents a plane. And the book cover also represents a plane. Now, when we talk of defined terms, these are the terms that have a formal definition and can be defined using geometrical terms and which are subject to rules of reasoning. Say, for example, collinear points. These are points that lie on the same line. So in this figure, we can see that there are 3 points that lie on the same line. We have point A, point B, and point C. They lie on the same line, therefore, points A, B, and C are called collinear points. We also have here non-collinear points. When we say non-collinear points, these are the points that are positioned in one place where there is no line. It is not feasible to draw a line through the non-collinear points as the points are situated at different places. Say, for example, we have here 3 points named point Y, point X, and point J. So it is not feasible to draw a straight line because these 3 points are non-collinear points. Therefore, the points X, Y, and Z are called non-collinear points. Another one is coplanar points. These are 3 or more non-collinear points that lie on one plane. Say, for example, in this figure, we have here 4 points lie on one plane. Points G, point A, point M, and point E lies on plane P. Then, these points are said to be coplanar points. Next, we have coplanar lines. A line which is in the same plane as another line. So in this figure, we can see that plane Q contains line 1, line 2, line 3, and line 4. Then, the lines are coplanar. Next, we have intersecting lines. 2 or more lines which share exactly one common point called the point of intersection. The intersecting lines meet at one and only one point, no matter at what angle they meet. So in this figure, we can see that there are 3 lines that meet at only one point, and that is the point of intersection. So therefore, lines 1, 2, and 3 intersect at point B. Next is line segment. Its length is finite and is determined by its two endpoints as shown in the figure. So this figure can be named as line segment AB or can be written in AB with an endpoints A and B. Perpendicular line. A line is said to be a perpendicular to another line if the two lines intersect at a right angle as shown in the figure. So this figure shows 90-degree angle and it is a right angle. So lines that cross a right angles are perpendicular lines. Thus, line AB and line MN are perpendicular or written as AB is perpendicular to MN. Parallel lines. Two or more lines that are the same distance apart, never merging and never diverging. Parallel lines are never ending. It continues in two directions and always the same distance apart. To be two parallel lines, both lines must exist in the same plane. So in the figure, we can see two parallel lines. We have line M and line N. They have equidistant. So the figure shows that two lines are parallel lines. Thus, we can say that M is parallel to N. So that figure read as line M parallel to line N. Now let us take a look on the real-life examples of defined terms. So the figure shows collinear points. This figure shows intersecting lines. So we have there three figures that shows intersecting lines. Perpendicular lines. So we have there the two lines that intersect at only one point, and it forms a right angle. This is also an example of a perpendicular line. Parallel lines, the lines in the sheet of paper. Also, this represents parallel lines. Now let us discuss definitions, postulates, and theorems on points, lines, angle, and angle pairs. When we say definition, it is a statement of a meaning of a term, the act of making of something definite, distinct, clear, or clarity of visual presentation. When we say postulate, it is a statement also known as an axiom, which is taken to be true without proof. And when we say theorem, it is a statement which has been proved true by a special kind of logical argument called a rigorous proof. Once it has been proved, it is 100% certainty that is true. Now here are some examples of definition and theorems. Definition of a midpoint. In the figure, you can see 3 points on the line. If points P, Q, and R are collinear, and Q is the midpoint of PR, then PQ is congruent to QR. Thus, midpoint divides the line segment PR into two congruent line segments PQ and QR. Next, we have definition of angle bisector. In the figure, if QS bisects angle PQR, then angle PQS is congruent to angle SQR. So the tick there indicates that the two angles are congruent or equal. Ray QS is what we call the angle bisector that divides one angle into two congruent angles. Next is definition of supplementary angles. Two angles are supplementary if the sum of their measures is 180 degrees. So in this figure, the measure of angle XAZ is 132 degrees plus the measure of angle ZAY is 48 degrees, and that is equal to 180 degrees. Thus, angle XAZ and angle ZAY are supplementary angles. Next is definition of complementary angles. Two angles are complementary if the sum of their measures is 90 degrees. Say for example in this figure, if the measure of angle LAM is 55 degrees and the measure of angle MAB is 35 degrees, that is equal to 90 degrees. Thus, angle LAM and angle MAB are complementary angles. Next, we have the definition of linear pair. Linear pair is a pair of adjacent angles formed by two intersecting lines. And the linear pair theorem states that if two angles form a linear pair, then they are supplementary. For example, in this figure, we have two intersecting lines, line M and line N. And the angles formed are angle 1, angle 2, angle 3, and angle 4. Linear pair of angles are angle 1 and angle 4. They are adjacent. Angle 2 and angle 4 are also adjacent angles. Angle 2 and angle 3 are also adjacent angles. Angle 1 and angle 3 are also adjacent angles. Thus, the linear pair of angles are supplementary. Next, we have the definition of vertical angles. Vertical angles refer to two non-adjacent angles formed by two intersecting lines. And the vertical angle theorem states that vertical angles are congruent. So in this figure, there are two intersecting lines and form four angles. We have angle 1, angle 2, angle 3, and angle 4. So in this figure, angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4. Thus, the vertical angles are angle 1 and angle 3, and angle 2 and angle 4. So, the two angles that are vertical are congruent angles. So, we have some examples of postulates. Postulates of undefined terms. 2 points are contained in exactly one line. So here, point Q and point P contains line M. Every line contains at least two distinct points. So in this figure, line M contains two distinct points, and these are point Q and point P. If 2 points are on the plane, then the line containing this point is also on the plane. So we have here point G and point H lies on plane B, and point G and point H contains line GH. Then the line GH is on the plane. Every plane contains at least 3 non-collinear points. And here, point G, H, and U are non-collinear points contained on plane B. Any 3 points lie in at least one plane, and any 3 non-collinear points lie exactly one plane. So in this figure, we can see that plane Q intersects plane P, and their intersection is line XY. So if 2 distinct planes intersect, then their intersection is a line. Segment addition postulate. If points P, Q, and R are collinear points, and Q is between points P and R, then line segment PQ plus line segment QR is congruent to line segment PR. Next, we have angle addition postulate. In this figure, if ray QS bisects angle PQR, then angle PQS plus angle SQR is congruent to angle PQR. And that ends our discussion for today. So let us apply what you have just learned. On your paper, draw the figure based on the given situation. The given is line AN, line PQ, and line ST are coplanar and lie in plane G. Line AN and line PQ intersect at point D, and line ST intersect at line PQ at point U, but does not intersect at line AN. Again, given is line AN, line PQ, and line ST are coplanar and lie in plane G. Line AN and line PQ intersect at point D, and line ST intersect at line PQ at point U, but does not intersect line AN. Okay, so the figure shows this solution. Did you get the correct answer, students? I hope you got it right. Thank you for listening, students. Always remember, geometry keeps you in shape. Again, this is Teacher Monica, your Math 8 teacher.